Now let's observe possible areas of AI application in telecom, in mobile networks at different levels. So first of all, let's start with the fact that many wireless challenges can be solved with a deep understanding of fundamental wireless techniques and things. But anyway, there are very persistent issues. One of the most significant challenge it is for example, inherent difficulty in accurate modeling wireless channels. Despite in advancements in channel modeling over the past 30 years, still models are not so perfect, I would say. And actually models are never perfect. For the air interface between base station or access node and user equipment, we can use AI, ML algorithms, techniques to potentially improve almost everything. It could be scheduling mechanism, adaptive modulation and coding schemes. It could be AI-aided data codecs to improve compression. It could be beam management, channel state information knowledge, channel modeling, and so on and so forth. Almost every aspect, I think. At equipment level, we can design some parts of receiver and transmitter to improve their parameters. Don't worry, we will overview that topic as well. From overall network layer, we can improve self-optimization features, capacity planning, and troubleshooting. For example, root cause analysis automation when we use machine learning algorithms to find patterns in how network works, wrong configurations, and such algorithms can not only identify and classify network issues, but also give recommendations on how to solve these issues, or even perform automatically tuning. And this is actually some kind of closed loop optimization. This is kind of final stage of almost all optimization tools for mobile networks, kind of zero touch approach with almost zero human, it means engineer intervention to the network. At radio access network level and point of view, we can use AI for dynamic interference classification and mitigation features, for load balancing, AI analytics. For network planning, we can automatically choose a new site selection where to build or which site needs to be modernized. Moreover, there is very promising concept. It is a concept of self-designing protocols or even networks. Don't worry, we will also cover that topic as well. There is also a possibility to create AI-added codecs for low latency communication to reduce latency, to predict some behavior in the traffic, for example, while you have a connection. So AI-added codecs for semantic communication for the purpose to compress data. When it comes to positioning and joint communication and sensing techniques, first of all, this is very similar. I mean, positioning and joint communication and sensing, they are very similar approach, very similar physics, especially in the case of non-line of sight. And traditionally, wireless positioning features relies on angle and timing information. However, in indoor environments, we usually have limited number of antennas, and accurate angle-based positioning is very challenging. Additionally to this, time of flight methods can be unreadable, unreliable due to multipath propagation, because multipath reflection from different objects inside indoor, yes? And to overcome these limitations for positioning, for joint communication and sensing JCAS, we can use machine learning to enhance fingerprinting techniques. So by training neural network on a diverse datasets of indoor environments with complex multipath propagation, we can accurately help to find location information even in very challenging non-line of sight scenarios. What else we can do? We can actually create special personalized chatbots or virtual assistants, or we can say AI agents at device level or network level, which will help engineers or subscribers, to solve some issues. For engineers at network level, they may help to and give advice how to maintain network, what should be done in order to increase KPIs. And such chatbots or AI agents may be based on special large language models that could be trained exactly to understand specific telecom languages, such as 3GPP specifications or IEEE papers. The main point, which also very important, is that analytics and predictive AI, statistical methods and mathematic, basically, it is not new for telecom, for mobile networks, but generative AI is new for telcos. And it's important to understand that only by working together, wireless experts, engineers, and machine learning specialists, they only by working together can drive 5G advance and future 6G networks to unlock new possibilities to solve a lot of issues, but we still struggle with a lot of issues. It's important to understand that AI is not a magic. It's just a possible tool, a solution for positioning, for improving KPIs, for forecasting, but AI ML can make the difference in those areas. At the end of this slide, I would like to be more specific about the power consumption challenge. I didn't mention here, but I think it should be mentioned, especially on a device. Adding new features often leads to increased power consumption, which is a major concern. We know that any AI solutions, tools known for its computational intensity, for power consumption, and it will drive additional requirements for battery life, for network sustainability, and again, power consumption. So this is a critical issue and demands the attention of engineers and researchers, because we need AI solutions that will add just a few or just a little bit power requirements to devices and network itself.